Good morning, boys and girls. Welcome back to the eastern wing of the Stinkbug Works. I've been thinking, and when I've been thinking, something bad is going to happen. And so here's something bad that's going to happen. Big B showed me a boat on eBay and I bought it. And I bought it for $99 plus tax and shipping. Anyway, it's a cool little hydroplane boat. And quite frankly, I think it was ahead of its time. The construction materials were current with the day's time, but it had a brushless motor, and I believe it was running a little wire drive. Now, it's an oddball size wire drive, and so it can't readily be replaced, especially now, since Aquacraft is long out of business. So, first thing I'm going to do is I'm going to rebuild it. And I'm going to put a 29 size motor in it, maybe a 28. We'll get to that. But here are a bunch of 29 sized motors and one 28 sized motor. This is an 1112 1.5 Delta. It's almost 4,900 kV. A screaming 2S motor with a small prop, but I think that's going to be way too much for that little boat. So this guy is out of the question. Next is the smallest rocket motor I could find, and this is a 2948. And the KV is just about right for 2 or 3S. It's 3450, so you could run this on 3S and get away with it. So this is an 1112. This is the equivalent of an 1110. So it's a bit shorter. You know what? Here's an interesting thing. I want you folks to take a look at it. And especially in this back end bell, can you see in there where you can see the stator? And you can see the wires on the stator. I don't know if you can see in there or not, but I can see iron in there. And can't really see it there, but this is where the wires are twisted. Now, look inside any typical new motor, and you will find it's packed full of copper. You don't get to see any iron. It's packed full of copper. I mean, it's jam-packed. Here's an older one of Steve's motors. This is the one I'm going to put new bearings in. No, that's the one that gets new bearings. But Steve, he packs these things full of copper. Look at that. I mean, that sucker is full of copper. You know, when you're looking at motors, you have iron losses, copper losses, and what's the other one? And friction losses. And so you have all these losses that you have to deal with. Hacker totally eliminated the iron losses by getting rid of the stators and just having wires that were glued inside the motor can, and then the armatures went inside there. And granted, the iron losses went to zero because there was no iron. But his copper losses went up so much that it essentially negated it. There is no free lunch. Let's talk about free lunch. These two motors are essentially the same. This is an Aviox 1005 1Y. Now, the number 10 refers to the outside diameter of the stator. So this is a 1005, meaning the stator is 1 inch in diameter. And the 05 refers to the length of the rotor. So it's a 1 millimeter outside diameter stator and a 1/2 inch long rotor. So that made a 1005. This is an 1105. It uses the same rotor as this motor. Well, this one has a 5 millimeter shaft, but the same design rotor as this one. It has a few improvements over time. And this one is an 1105. That means the stator diameter is 11 or 1.1 inches. So he added a 1/10 of an inch to the stator design. That took it from a 28 millimeter motor to a 29 millimeter motor. The 29 millimeter motor with the slightly larger stator, yes, your iron losses will increase. But your other losses will decrease to where Steve discovered this, oh God, it had to be been in the early 1980s when Steve discovered that, you know what? Slightly larger diameter on your stator, while it drops the kV, seriously increases the efficiency. And in Steve's world, it's all about efficiency. That's all that matters. Because you can have any wind motor you want. You can find the RPM per volt you want. You can find the torque constant you want. You know, you can look in the charts and you can find the motor you want. And there it is. Boom. Doesn't matter if it's, Rocket, Triple S, TP, New, Aviox. There'll be a motor and it'll be a given RPM and a given torque constant. Because that's all you really care about is torque and speed. Well, here's the difference. Steve's motors at that torque and that speed use less battery than the next guy. Or, in another way of saying it, at wide open power, when the batteries are dumping everything they've got, since these motors are a little bit more efficient, they'll turn it a little bit higher RPM for the same voltage and same amperage. So efficiency is where it's at when, especially you're racing, and F5B is a race, let me tell you. You want every ounce of efficiency you can get. And in fact, the European boats are doing this. They're putting watt limiters in. So you only get to use so many watts in a race. And if you're more efficient than the next guy, you will get more out of those watts than the next guy and improve your chances at beating the next guy. Now, you could drive like crap and blow everything out of the water, but you follow what I'm saying. So here's what we're going to do with this Miss Seattle. This is way too big. This is too big. This, while air-cooled and a little bit smaller, 1107, I think it's still a little bit too big. I think the slightly smaller 1105 would work. But since I'm giving this away as a prize in a future upcoming challenge, as a future prize, the next challenge is going to have some really bad prizes. I'm going to use this Aviox motor. And yeah, this is a unicorn, but I think it would be the perfect application for the unicorn. And here's the deal. This is a 28 millimeter motor. I want to run it on this clamp because the shaft, I shortened the shaft because I used a prop spinner on it that, had to be there up against the motor mount. So this was in a little pylon racer. A stupid, fast little pylon racer, but a little pylon racer nonetheless. So I shortened the shaft. So I'm going to use this 28 millimeter mount, which is slightly different than the 29 millimeter mount. And that allows me to get this coupler closer to the face of the motor, and that way the shaft can go full length into here. I don't have to accommodate a 1/8 inch mounting plate. So that's what's going to go into the Miss Seattle. But wait. See this notch? This used to have sensors in it. That's how old this motor is. It was one of the first Aviox motors, and it actually ran sensors. Anyway, here's what I'm going to do. I'm going to make a cooling jacket out of this here bit of carbon tube. I was going to use this as a cooling jacket for something else, and for some reason, I don't know why, I gave up on it. Maybe it was because it was too short, too long, wrong dimensions, whatever. So I started it and never finished it. Anyway, here's what it's going to happen. It's going to go, you notice it fits just right in there between the motor mount and this little lip here. So I can get it in there. The problem is it crashes up against this support arm, and I'm going to have to cut out. You see where I kind of drew on a little thing? I'll have to cut out a little piece of that support arm to allow this water jacket, but it'll have this cool little water jacket. So that will be the power plant in the Miss Seattle. This thing, 5,500 kV. This is going to be a 2S setup, and it's going to turn a small 27 millimeter prop. I'm going to take a 427 and maybe cut it down to 26 or even 25 millimeters. And on that small Miss Seattle, I think that thing's a shade over 16 inches long. So here's a foot and 4 more inches. It's that big. It's that big. So a little 427 will be more than enough prop for that. And I'll turn it at, let's see, this is 5,500 times, let's just say times 8, 40, roughly 45,000 RPM at the prop. That should be just about right. Okay, enough of that. It had a little wire drive on it. I don't know if the wire drive will handle what this will put out. So I went through my collection of shafts. I have a long 98 thousandths flex shaft and a short 98 thousandths flex shaft. This one might be too short, and I know this one's too long. So if this one's too short, I'll use this one and cut it down, run 98th cable. I told you I'm going to run the ubiquitous strut and rudder, although I may use this rudder. I like the look of this rudder on a hydroplane, and I just think it looks better than this rudder. This rudder looks good on a mono. I like this on a hydro or a cat. But I digress. We're going to use whichever one fits. Lastly, okay, that's enough of the Miss Seattle. It will be here before the stuff from Germany ever arrives or the other stuff from the other country arrives. In the meantime, this is a PEC Polymers building board. It's a magnetic building board for building PEC polymer airplanes. And if you know anything about PEC polymers, they build rubber models. And so most of them are 24 inches is a big wingspan for PEC polymers. 30 inches and you're getting up into the huge area. So this is their building board, this little metal bit, and I had it glued down to a piece of particle board, and that particle board started to warp, and nothing I could do would unwarp it. So lacquer thinner is your friend. Lacquer thinner will remove the contact cement from the backside of this. See how nice the backside is? This was covered in glue yesterday. Today, it only has a little blob here and there. So we'll talk about this later when I'm going to build a wood boat. We'll have to see. Wood boats are not in my immediate future. Everything coming from Europe is made out of fiberglass or carbon fiber or a combination thereof. Maybe some Kevlar here and there. You never know. So there you go. I've been rambling on now for damn near 20 minutes. Oh, and I thought I had nothing to say. Until next time, boys and girls, jet out.